Question number 13. As observed from the top of a 75-meter high lighthouse from the sea level. So let's try to make this sea here. There's a sea here, right? And there's a lighthouse. There's a lighthouse. There's a lighthouse here, right? There's a lighthouse here. So it's giving you light. So from the sea level, there's a 75-meter tall lighthouse. 75-meter tall lighthouse, and it's telling you the angles of depression of two ships are 30 and 45. So there are two ships sailing. I'll just make it with another color. There are two ships sailing, right? There's one ship and there's one more ship, right? So there are two ships sailing on the sea, and you're having angles of depression from the top of the 75-meter high lighthouse. That means from this point, this is the top of the lighthouse, there are angles of depression. You know, there are angles of depression here and angles of depression here. So there are 30 and 45. So what we need to do is we need to make the angles of depression. If this is the horizontal line, now you're making an angle of depression. You're depressing your sight downwards to this ship, and then again downwards to this ship, right? So it's obviously the more more angle will be, I'll just show it by a red. The bigger angle will be this whole angle here, this one. This is 45, right? This which is closer, it's 45 degrees, and the ship which is far, the angle which it makes, the angle of depression, is only 35. So I'll make it by another color, 35. This is 35. This 35 degrees, right? No, sorry, this 30 degrees. Okay, so this is 30 degrees, not 35. So 30 degrees. So here you're having 30 degree and you're having 45 degree. But when you will use the when you're having two parallel lines, I told you before, having two parallel lines, it is a transversal cutting them. If this angle is 30, then this angle is also 30, right? In the same way, what we can do is we can make the angles on the downside, right? We can make the angles, I'll just show it by yellow. There's a line, there's a line, there's a line here, right? So, and the green lines are like cutting this yellow line. This green lines are cutting this yellow line like this, and this is cutting like this, right? So what do you say about the angle which is made here? So this is Z, right? Like this, this, and this. So this angle is 45, right? Because alternate interior angles. You forget this line which is in between and see this 45 here, right? Like this. So this is 45, so this is also 45. So we can make this as 45. And now you forget this line. You forget this line. Now you see this line which is in between. See this line, and this line. So this is also two parallel lines and one transversal cutting them. If this is 30, then this is also 30, right? So this is also 30. So we got the two angles, right? And we can name the triangles now: A, B, C, and D. We have to calculate the distance between two ships. So that means distance from A to B. Distance from A to B we have to calculate. So AB we have to calculate. And AB can be calculated as, if you know AC, the complete distance, from of one ship to the base of the lighthouse. If you know AC, and if you know AC, and then you subtract BC from it. then you will get AB, right? If you know AC and BC, you subtract AC and BC, you will get AB, right? Now let us do the trigonometric procedure to these two triangles, ACD and BCD. So let's take triangle ACD. Triangle ACD. In triangle ACD, you are given the angle, you are given the angle, you are given the opposite to the angle, and you want to calculate the base, right? So that means again tan of that angle, and that angle is 30 degrees. Tan 30 is opposite over adjacent, that is AC. Tan 30 is 1 by root 3. 1 divided by root 3 is 75 by AC. Or you can say AC is equal to 75 divided by 1 by root 3, right? Or AC, or I can write AC as, I can write it on the top. AC is equal to 75 multiplied by root 3, right? A by B divided by C by D is 75 by 1 divided by 1 by root 3, and that is AC is 75 root 3. So this is AC. Now let us use one more triangle, BCD. Triangle BCD. In triangle BCD, again, you're given the opposite, you're given the angle, you're given the opposite of the angle, and you have to calculate the base, BC. So again, you will take tan 45. Tan 45 is equal to 75 divided by BC. Tan 45 is 1. So BC multiplied by 1 is BC. BC is 75. So BC is 75. If BC is 75 and AC is 75 root 3, then AB equals, which I have already written, AC minus BC. AC, that is 75 root 3, minus BC, that is 75. So you can take 75 as common. 75 times root 3 minus 1 meters. And this is the distance between the two ships.